Hello everyone, Assalamu alaikum. I am Ryan. Last year I competed in the International Youth Math Challenge final round and got bronze honor. Alhamdulillah. So I think of making a tutorial video of the math problems that were given in the pre-final round. So in this video I will be discussing the solutions of the problems which are fully correct. I won't discuss other problems because I ain't confident enough. Maybe my solutions are partially correct or maybe wrong. However, I don't want anyone get any wrong information from this video. International Youth Math Challenge will publish their official solution after some months. So I will put the problem link in the description as well as timestamp for each of the single problems. So let's start. The first problem, A.1, was find on all points xy a coordinate xy where the functions f of x, g of x and h of x have the same value. That means these three functions will have a same intersection point where these three functions will give us a same value. So we have to determine a coordinate xy where these three functions will give us same value. So this can be solved by comparing these three functions sometimes. Also a better way was to draw the graphs of these three functions. So I drew the graphs of these three functions, okay, like here, and then we can see that these three functions intersect on 1 point 8 and 11. Here these three functions will be intersect on 1 point 8 and 11. You can also see the graphs of these three functions by some online tools like desmos.net, and then you can see that these three graphs will intersect on point 8 and 11. You can also verify by yourself that 8 and 11 if we pass this point through any equation. Like here f of x is 2 to the power x minus 5 plus 3. So if we pass 8 and 11 here like this, 2 to the power 8 minus 5 plus 3, we get 11. So that was the answer, that the point xy is 8 and 11. So the next problem was A.2. Here you have given a function f of x and you have to determine the roots of this function. So 5 to the power twice x minus 6, we can treat it as a minus b whole square, and we know that a minus b whole square formula is a square minus twice ab plus b square. And if then simplify this whole function, we get that 5 to the power of 4x minus 13 into 5 to the power twice x plus 30. And then we have to do middle term factor here and then take common that parts which are commons, and then we get this line that 5 to the power twice x minus 3 into 5 to the power twice x minus 10. So we can now see that if we took 5 to the power twice x minus 3 equals to 0, we get one root if we denote as x1, that is ln 3 by 2 ln 5, and get another root x2, that is ln 10 by 2 ln 5 by comparing 5 to the power twice x minus 10 equals to 0. So that was two roots of the following function. So then let's go to next problem, that is A.3. We have to find derivative of f of x of the following function with respect to x. Here f of mx is summation of n starts from 1 and goes on till m. n to the power x into x to the power n and whole square. So to solve this, we need to know that is summation sign, and here n starts from 1 and goes till m, like 1 2 3 dot 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 m. So if we put n equals to 1, we get that f of 1x 1 to the power x into x to the power 1 and whole square. So the function was x square, and if we do differentiation we get twice x. Similarly, for n equals to 2, we get 2 to the power x into x square and whole square. And here the differentiating rule is uv function, and we know that if we differentiate two functions u and v, the resulting derivative will be u into ddx of v plus v into ddx of y. So that was the formula. So if n equals to m, what will be the function? It will be m to the power x into x to the power m whole square, and then again do differentiating. So by checking n equals to 1, 2 and m, we came to a conclusion that for all n where n equals to 1 and goes on till m, the derivative of the given function will be 2 into x to the power m into m to the power x into summation and this function x to the power m into m to the power x into ln m plus m to the power x plus 1 into x to the power m minus 1. So this portion 2 into x to the power m into m to the power x will be common for all the values of n, and thus the function we get that derivative of the given function. So I hope you understand. Now let's go to next problem. That was b.1. So here we have given a sequence of successive numbers of the 2 to the power kth power, and the sequence was 1 2 to the power 2 to the power k, 3 to the power 2 to the power k, and thus goes on. We have to tell show that difference between the numbers in this sequence will always be odd. So this kind of observation problem, my solution was like, if we put k equals to 0 1 or 2 or 3 dot dot, we get a sequence like this. For k equals to 0 we get 1 2 3 4 5. For k equals to 1 we get 1 4 9 16 25. For k equals to k equals to 2 we get 1 16 81 256 625 and so on. So the main observation here was that we see that whatever the value of k, it doesn't matter, we get always sequence like odd even and odd. So whatever the value of k, the sequence will always be like that, odd even and odd. So as we know that odd minus even equals to odd and even minus odd equals to odd, so this was the main point of this problem. So for all k belongs to natural number or n, the sequence, the difference between the numbers in the sequence will always be odd. So that was how I showed that it will be always odd. So let's go next problem. So b.2 I have solved it using ratio test, but I ain't sure. I guess there will be much better solution, so I want to discuss. So the next problem was c.1. This was a prime number related problem, and the theorem that explained here is sieve of Eratosthenes. We know that we use sieve of Eratosthenes for checking if the number is prime or not, but there the questions was like kind of proof, so I won't discuss, sorry. So let's go to last problem, that is C.2. For C.2 we were given a research paper. I will also put that research paper in the description. The research paper was about harmonic and hyperharmonic Fibonacci numbers. So let's start with problems. The first problem was we have to find the values of h of n, f of n and bold f of n, where h refers to harmonic number, f refers to Fibonacci numbers, and bold f refers to harmonic Fibonacci numbers. So I guess we all know what is harmonic number and what is Fibonacci number. Harmonic number is the basically summation of 1 by k, where k equals to 1 and starts and then goes on till n, and Fibonacci number is the sum of previous two numbers, and the new thing was harmonic Fibonacci numbers. So you can see the definition here. So we have to find the values of these three functions in case of n equals to 1, 2 and 3. So for Fibonacci numbers, that was, we know that 1 1 Fibonacci number starts from 0 1, and the second will be 1, and the third one will be the sum of previous two, that is 1 1 1 plus 1 equals to 2, and harmonic number will be 1 3 by 2 and 11 by 6. Using the formula, using this formula we can know the h of 1 2 or whatever the value of n, what will be the harmonic number. The same for harmonic Fibonacci numbers. By using this we can know the what will be the value of harmonic Fibonacci numbers. Well, the C.2 was consist of 7 problems, I guess. 8 problems. 2 problems was given extra to get bonus points. Okay, so the problem C next was, we have given a following fraction and we have to simplify the following fraction, and we can see in the paper that x to the power m bar is, okay, just wait, let me here. We see that x to the power m bar is equals to x into x minus 1 into x minus 2 and goes on, and the last term will be x minus m plus 1. So using this line we need to solve the following fraction. So if x to the power m bar is x into x minus 1 into x minus 2 goes on x minus m plus 1, then x to the power m plus 1 bar, the last term will obviously x minus 1, can be easily understand, and then we written down this line and we took common that what part can be take common part here, and then I take this common and this both portion will be cut from both denominator and nominator, and this remaining part will be, that is x minus 1 minus m divided by 1 minus x minus m. So the given simplification of the following fraction will be this, x minus m minus 1 divided by 1 plus x minus m. So then let's go to the next problem, that is E. Here we have to show that left hand side equals to right hand side. We were given a hyperharmonic Fibonacci number hyperharmonic Fibonacci number, that is bold F of N and R. So we see there is a relation, a recurrence relation of hyperharmonic Fibonacci number, that is f of bold nr equals to bold f n to the power n r minus 1 plus bold f n minus 1 to the power r. Using this recurrence relation, we can prove the following this line. So to prove this, I first simplify it. If bold f n r equals to like this, that is f n to the power r minus 1 plus f n minus 1 to the power r. In the next line, then again we have to apply this recurrence relation again in f n minus 1 to the power r. In that case, we get f n minus 1 to the power r minus 1 plus f n minus 2 to the power r. And as we can see that this plus of n minus 2 to the power r and minus f n minus 2 to the power r both cancel each other, and the remaining part is f n to the power r minus 1 plus f n minus 1 to the power r minus 1. So that was the right hand side. So we can see that we proved left hand side equals to right hand side. So that was all. This was my first time making a tutorial video, so please pardon me if I have done any mistakes. Let me know how was that video. Next video I will be discussing other problems. So, and this was that bronze honor, alhamdulillah. So that was all. Thanks.